Good afternoon, wherever you are. My name is Arun Gupta. I am the Vice President and General Manager of Open Ecosystem Team. You can find all about us at open.intel.com. We also have a wonderful podcast at open.intel.com/podcast. If you want to be a host, if you want to write an article, let us know. We are always available and always looking for wonderful contributions over there. Happy Friday. And today I'm here with Kate. Hi, Kate. Good morning.
Hi, Arun. Thank you for having me. A great way to kick
Absolutely.
the end of the week.
End of the week. This is a great way to start the end of the week, essentially. You know, as we were discussing before the webinar, is like this is like a hallway conversation. Imagine I bumped into you in a hallway at a conference, and I get to talk to you. I get to know about you a little bit, and learn about the technologies that you are deeply involved with, and your excitement and your passion around all of that. So instead of doing it in a conference hallway, imagine we are doing this in an interactive manner and making it accessible to a wider set of people. So that's the joy of it.
That's a great format, and I think we just kind of ended one conference season with KubeCon and in the WebAssembly world, Wasm.io. So I wasn't able to attend those in person, so I'm happy to pretend I'm at a conference right now.
Awesome. Okay, think of this as totally as your virtual hallway in that sense. Although the conference season is not ending because next week is the open source summit. So I'm going to be there and hopefully we'll meet a bunch of open source friends over there.
That's actually a good point. I will also be there, so
Oh,
we will
cool.
be in person. So maybe
Oh,
we can find
lovely.
a true hallway.
What a joy. Then we will definitely get set up time to see each other in person then. Awesome. Kate, do you want to introduce yourself?
Sure. Hello, everyone. Thank you for tuning in. I'm Kate Goldenring. I'm a software engineer at Fermyon, where we're really passionate about serverless WebAssembly. And before that, previously, I was at Microsoft, where I was focused on the IoT Edge world of Kubernetes. So I'm co-chair of the CNCF IoT Edge working group and developed a CNCF sandbox project called Aukri. And then from there, I got interested in WebAssembly through trying to integrate WebAssembly with Aukri, and then ended up leaving to join Fermyon and enter this serverless WebAssembly space, and have been exploring that space ever since. And I'm within that passionate about making WebAssembly more accessible as a concept. So I'm co-chair of the Bytecode Alliance's documentation SIG. So we have some books out there that are trying to make it easier for you to jump into this whole new world of WebAssembly and components. So I'll try and point to those resources as well as we go along.
That's awesome, actually. Yeah. So serverless WebAssembly, I think that's a unique combination, and I definitely want to dig into that a little bit later. But before we dig into that, and you said Fermyon, the company where you work at, is about creating the serverless WebAssembly app. So we'll definitely talk about that. But before we dig into that, give us sort of a state of the union. WebAssembly has existed for a very long time, but more recently it is gaining more traction and a lot more becoming visible and getting a lot more attention. So tell me what's going on and what's sort of the state of the union today of WebAssembly.
Yeah, and in order to do that, I want to pull a visual, a roadmap. And
Sure.
the roadmap it was created by Bailey Hayes, who was actually on the show a few months ago, or I think it might have been November, so more than a few months ago, time's flying.
Yeah.
But we've had some pretty big updates since then. But the great thing about those updates is that they were anticipated. And so you'll see that this roadmap was from July of 2023, but it's held true. So I'm going to go ahead and zoom into it here. Oh, that's a video. One second. Let me go back. We also have a screenshot of it down here. There we go. So here's the roadmap. And in July of last year, so almost a year ago, we had some goals for WASI. And to take a step back, we have WebAssembly, which I want to take a moment to talk about what WebAssembly is for folks who may not have tuned into your previous live stream. But WebAssembly is a couple of things. It's a bytecode format, so it's a target that your language compiler can target. And it's also beyond that an execution environment. So it's a runtime, whether that be the browser or a runtime that can run directly on your machine, that can execute this WebAssembly within a sandbox. So because of that, people think of WebAssembly as this great portable bytecode that can run on any architecture, any operating system that's really small, but they also think of it as a VM because it's isolated in linear memory by the runtime. So I
So
just wanted to, sorry, go
let's
ahead.
take a pause there for a second. I can write a code in a language and I can translate that into a bytecode, as you said, one component of WebAssembly. And then the second piece of it is a runtime, which is could be running on a desktop, on a edge, on a data center, on a laptop, doesn't matter. But essentially, I could write a code in Rust or Go or whatever that language is, convert it into that bytecode, and then run it on any environment across the board.
Exactly, and the languages that are supported, it's not all of them, but it's many of them. So there's over 10 that have pretty stable support. And just to throw out a resource, we have a WebAssembly language support matrix here. And if you want to see what is the status of my favorite language, and its support for WebAssembly for targeting WASI APIs, and also we'll talk about Spin later if you want to use a developer tool to get started with WebAssembly. But you can see there's many different languages that you can compile to WebAssembly. And beyond that, that you can turn into components, which is another part of WebAssembly that we'll get to as well.
So if I go back 25 years ago, 30 years ago, when Java was created, that was the purpose of Java, that, you take Java, you convert that into a bytecode, it gives you a .class file, and it could run into a VM, and that VM is running on any device over there. How is this different?
Yeah, I think comparing it to JVM is one that we get a lot with WebAssembly. I think WebAssembly definitely learns from that, but it's aiming to support an even wider variety of languages, be even smaller and more portable. And a big part of it is that isolated runtime in linear memory. And also another big part of it is this concept of components. So it kind of takes that idea of this universal bytecode and execution engine and takes it further. And by applying a canonical ABI on top of it and a kind of a structure that makes it so that languages can talk to each other and compose and run isolated from each other. So it really just expands upon that vision.
So what I'm hearing is you're saying smaller, more efficient, more isolated, and that gives us the ability to possibly run it on a wider variety of devices. And Java is not the only language that can be converted to WebAssembly bytecode, but is pick a language of your choice, and then that could be converted into the bytecode because people are using all sorts of diverse languages these days.
Yeah, and another part of it is, and part of what I want to talk about today is components. And with WebAssembly modules, which was pre-WASI 0.2, you could compile all these different languages to WebAssembly, and those modules could interrupt, but they shared memory, and you weren't relying on as strict of types in order for them to cooperate. And so it was a little harder to get these different modules to cooperate and to do it in a way that it was they weren't sharing memory. And now with the component model, we have these new types and these interfaces so that these WebAssembly components can compose better. And to kind of get an image of that, with a module, you had a lot of these benefits. You had this portable bytecode, a small binary. It was isolated, like the actual module. It had fast startup times. I mean, these modules are quite small, and the runtime can execute it pretty quickly. Not as fast as native, but near native. And it's completely an open standard. And as we've mentioned, it's polyglot. So these are all great things. And what WASI 0.2 brought along is the component model. And what that does is it makes it really easy to compose two different modules together across these interface types. And so one module may export some functionality and the other may import it. And each of those is still isolated in their own sandbox, but they're talking over these like defined APIs. And so what the component model brings on top of just standard core modules is that fine-grained sandboxing. So you have this language interoperability, but each of these modules are isolated from each other, and they're composable now. And it's all across these very defined interfaces.
And so they're running in the same, like a Wasm runtime, but these are two separate Wasm binaries. One potentially exported from Rust, one potentially exported from Go. It doesn't matter what the language they're written in, because at the end of the day, it's the bytecode that is running in the runtime. And then there are legends that are followed in writing these components, which are exposing and importing and using these APIs, correct?
Yeah, and then just to clarify something there, they originally are two different binaries, two different .wasm files, but you use tooling to compose them into one binary. So at the end, you'll see we have one .wasm file
I see.
that was derived from two.
Gotcha. That makes sense because end of the day, you're solving a customer problem. They don't care about how these components are created, what the individual components are. End of the day, these components, you pick a component off the shelf, you compose them together, and you say, here is your solution, which gives them one single binary.
Exactly. And then they can execute that with the WebAssembly runtime of their choice. And the exciting thing about WASI 0.2, which was announced in January, is that it creates a set of standard interfaces. So WebAssembly Systems Interface, WASI, could also be thought of as WebAssembly standard interfaces. So it's the set of interfaces that runtimes can choose to support. So if I create a component that it ends up exporting one of those interfaces, it can run on a variety of runtimes that support WASI 0.2. And that's what's really great about WebAssembly is this, it's not only portable across architecture and OS, but also across runtime and therefore platform, which is what's really cool about this, this new type of application. And then to go back to that roadmap and kind of talk about what those standard interfaces are, with WASI 0.2, it ends up supporting two main worlds. So you have the HTTP world and the CLI world. And so these are worlds that your component can target, which means that at the end, my component could export something called incoming handler, and then a HTTP incoming handler. And so then my WebAssembly runtime could serve up my WebAssembly component. And so HTTP requests can come directly to my component because it understands what an incoming HTTP handler is. And then another, that could be Wasm time, which is one runtime, or it could be a variety of runtimes that support the HTTP world defined in WASI 0.2.
And so these are the handlers, the way they interact with each other, the components interact with each other?
Yeah, so let's go ahead and look at that. So let's go to, here's another resource, wasi.dev. And if you want to look at what these interfaces look like, you can actually go to wasi.dev and see what interface a component can support. And this is getting a little low level, so we can come back up if someone isn't interested in looking at the actual worlds that a component can target. But you'll see that basically these are strict interfaces that define the capabilities of a component. And so if someone is using a component that is exporting incoming handler, they can call that export. And so the WebAssembly runtime can call the exported incoming handler, and then the component can implement that incoming handler and receive those HTTP requests.
Gotcha. It's a very standard HTTP model, where you're just receiving a HTTP request, you act upon it, and then let the API between the two HTTP handlers do the real thing.
Exactly. And so it's basically taking those high-level concepts that already exist and putting them in a WebAssembly interface type format, which is called WIT. And so you'll see that this file is a .wit file.
Oh, .wit file. Okay. What does WIT stand for?
WebAssembly interface types.
Oh, WebAssembly. Okay, gotcha. Okay, yeah. I'm always amazed by these new extensions and interfaces that comes along. And I do remember, when a few months ago, when Bailey was on this interview, she did talk about WASI 0.2 and components. So it's really good to see that becoming a more reality now. What other things are happening as part of WASI 0.2?
Yeah, so with WASI 0.2, we got the component model, which we've talked about a little. So with WASI 0.1, we didn't have the component model yet, but WASI 0.2 brings in a new set of types and brings upon the component model, and it also defines new interfaces. And so, and the concept of worlds. So we have the HTTP world that we were saying we could support, the CLI world, so you can run from command line. And then we also have a few new interfaces, namely the HTTP interface, streams support. So, but the main thing about 0.2 it was this movement in the ecosystem to create a standard set of interfaces that everyone can version and align on. So now we have this stable release that everyone can target. And if your WebAssembly runtime supports 0.2 and your WebAssembly component is targeting 0.2, that they will be friends and be compatible. And so it's really this alignment of the ecosystem with compatibility support and a full feature set.
I think that's a big deal because that really allows is not just my components working with each other, but it's my components working with components from a different vendor and truly being able to make those composable applications. And that's where I believe the value starts emerging out, because now I can truly look at sort of the WebAssembly app store and start picking components and choose and compose them accordingly.
Exactly. And to go back to Bailey, who will be our third star of the show, she and I gave a talk at WasmCon North America, I believe, last year, where we showed this. So we took a component and we had it target the expose the WASI HTTP world, and we ran it on Wasm time locally, which is a runtime that is created by the Bytecode Alliance, which is the organization that's kind of corralling all these efforts. And then we took that same component and ran it on Fermyon Cloud, my company's WebAssembly cloud, and ran it on Cosmonics Cloud. And so that shows the lack of vendor lock-in. And when we talk about the serverless story, which is what we're excited about, that's pretty big. I think people's serverless experience in the past has been a lot of vendor lock-in. But with WebAssembly, you can have these reactive event-driven apps that don't have vendor lock-in because they can target these clearly defined interfaces.
That's massive, actually. The fact that you could take a runtime and run it on both the vendor clouds, essentially, because in Kubernetes, we talk about that, yeah, you can run it, but then, in Kubernetes, you quickly get into, like, what is your networking interface, or whatever is your storage interface, and all of that complexity rather quickly gets into the way. And even though the APIs are compatible, even though the distros are compliant, but the applications are not truly portable. Moving my application from one vendor to another vendor could be really a nightmare. So it seems like that's a different dream and a reality here.
Yeah, and I think another part of that is what you were saying about those network interfaces is with WebAssembly, I don't have to create all these services. Like I don't have to create the server in my application. The runtime can be the one person implementing that. And then my application can just focus on how does it handle an HTTP request, not how does it serve up a listener. And that's really big too. If we talk about security vulnerabilities in that part of the stack, you can just focus on your business logic, and then you only need to the host runtime needs to worry about patching that. You don't need to rebuild and redeploy all of your applications. And so really your component can just have the code that it needs.
That's wonderful. Okay. Anything else that you're excited about WASI 0.2 particularly?
I just want to call out that in that roadmap, the next phase is 0.3, and people may be thinking, okay, what's next? And that's support for async. So making it so that components can interact with each other in an async manner. So basically, if one component's doing some file I/O, the other component can resume and it isn't blocked on that.
Gotcha. And what is the timeline for 0.3?
I think it's another year. So at Wasm.io, I think Luke Wagner was giving an overview on his vision for async for the future and mentioned that 0.3 will probably be in a year. There is some work to come up with some async support in kind of a workaround way that may come sooner. And Joel Dice at my company has been working on that and upstream in the Bytecode Alliance. So overall 1 year, but it might be sooner.
So as an outsider, I might wonder that, hey, it's taking them a year to go from 0.2 to 0.3. Is the app mature? Is the spec mature? Is the standard mature? Or are they moving too slowly? How should I parse it? How should I grok it?
Yeah, I think when you're working with open source communities and standards groups, things move slowly. I think that's a good sign to kind of get a peek under the lens the way that WASI 0.2 got released was that the WASI subgroup voted, and if it's unanimous, it's released, and we do that for all of the interfaces that are created. So there's more interfaces coming, such as key value. What does it look like for a component to interact with a key value store? Or what does it look like for a component to interact with a runtime configuration? Or for an I2C interface. And so for the embedded space. And all of these will be voted on and go through several phases of iteration. And that site, wasi.dev, kind of that talks about the phases that you go through and how you can create your own interface too and propose it to the WASI subgroup or even join the WASI subgroup. So all this is being said that when an interface is released into a release of WASI, it's been pretty highly vetted. That doesn't mean that those interfaces don't already exist. So they're out there, you can still target them. It just means that runtimes may not stably support them.
I hear you. So with a release every year, am I looking at 1.0 in 2030? What's sort of the time frame we're looking for 1.0?
That's a great point. And also there are sub-releases. So for example, 0.2.1 is coming soon and 0.2.2 will come after that. And so we're trying to get into an iterative, faster releases. 1.0, I am not personally sure what our criteria is for what 1.0 would look like for the component model. My understanding would be that we would have all of these 1.0 for the component model and for WASI. But I don't think we're looking at 30 years. I think we're moving at a faster cadence already. So I'm hopeful that that won't be too far in the future.
Okay. Well, I meant 2030, like, because if it's 0.2, 0.3.
Oh, 2030. I gotcha. Yeah.
Well, that's good, and I can understand sometime based upon the maturity of the spec and the adoption of the implementation, you may decide that, okay, you know what, we are 0.4, 0.5, but it's looking pretty good, and just jump straight to 1.0, which is totally fine. So I think, and again, I'm not judging because I've been part of several open source communities. I appreciate the diligence and the vetting that goes on because people are actually betting their companies and their careers and their products on it. So the more we can make them, behave better in the open source community in terms of the API, in terms of the compliance, in terms of the performance, in terms of the security, the better it is. I really, really respect people who take time to make sure it goes through.
Yeah, I think there's a reason for process, but I think you're right. It will jump to a point where, say, we're at 0.6 and we feel great about it. We'll jump to 1.0. I don't think it needs to be linear.
Exactly. No, that's fair. Okay. Now, WebAssembly is great, but over the last decade or so, we have seen, CNCF, Cloud Native Computing Foundation, their mission is to make cloud computing ubiquitous. And what has happened is it has become ubiquitous, so anybody and everybody is using Kubernetes cluster, whether it's going to a different planet, whether it's going under the earth, ocean, on this planet, data center, whatever. I mean, people are using Kubernetes in all creative, fun, exciting ways. What is the relationship between WebAssembly and Cloud Native?
Yeah, so we talked a fair bit about you can run WebAssembly everywhere, and people's follow-up question may be, how do I get started? How do I do this? And one of their big questions may be, can I put this on Kubernetes? And I think Kubernetes has just kind of entered every space of cloud native. And so the answer is yes. And you can also get started using it pretty fast as well. And that both of those questions and the answers to those questions are stuff that we're pretty excited about at Fermyon. So I spend my day-to-day making sure that people have better experiences with that. So making sure you can get started building WebAssembly applications quickly and actually deploy them to Kubernetes now. So if it would be okay, I'm happy to transition to showing a quick demo of, can I just go ahead and build WebAssembly right now?
Let's do it. I mean, that's so awesome, actually. Yeah, I would love to see, like, I'm a Rust developer, I'm a Go developer, whatever, right? I mean, pick a developer that suits your profile. And so far, I've been taking those applications, building Docker containers and deploying them as Kubernetes pods. What does my life cycle look like? Where does WebAssembly fit into the cycle? And what tools do I need to be familiar with? How can I deploy those on cloud native? And more importantly, why would I do that? Like, what benefits does it provide me as opposed to deploying a Docker container directly versus a WebAssembly in the cloud native runtime? Like, what are the benefits?
Awesome. Okay, so let's answer those questions. What is my workflow as a Rust or Go developer? Why would I do this? Where can I put it? So to start, for workflow, I'm going to go ahead and reshare my screen.
Yeah.
So I'm going to start with Spin. So Spin is an open source project that we have created at Fermyon a couple years ago. And the goal of Spin was to make it so that you can have a very quick startup experience with WebAssembly. And it simplified that to a few commands. So to start with Spin, you'll just install it. We have a script for that, or you can go to releases. I already have it installed. So I'm going to go ahead and bring it up in my terminal here. Did this switch for you? Can you see my terminal now?
I can't see a terminal.
All right, let's do a different method of sharing.
Yeah, I think this is maybe RFA we need to file on Restream. I wish Restream was an open source project, but we can, as a customer, we can definitely send them a request that, hey, we really need. Was that that background picture? What is that? That's beautiful, actually.
This is base camp for Mount Rainier if you're doing the Emmons route. So this is Sherman camp. Yeah. So
and have you done that?
Yes, I'm a mountaineer as a hobbyist. So when I'm not in front of my screen, I'm hopefully outside. So yesterday I was doing a conditioner hike on the Cable Line Trail, if you're familiar with it. It's just a grueling, like 2,000 feet and a mile and a half uphill with a ton of weight. But it really clears the mind. It's a great way to kind of reset after a work day.
Oh my God. Yeah. I mean, it totally does. I'm not as intense a mountaineer, but in a few weeks, we are actually climbing Kilimanjaro. So I think that's going to be an exciting one. Yeah.
Definitely on the bucket list. Well, that sounds like that'll be after Open Source Summit. So hopefully there's another conference after that I can ask you all about it.
Absolutely. Yeah, we are going end of May, early June, climbing Mount Kilimanjaro. It's a 7-day climb, and then we'll also do like a 4-day Serengeti safari after that. So I'm super excited about it. And the whole family is going, so that's amazing.
That is a wonderful trip, and I hope you blog about it so I can
Thank you. I will
do exactly day by day.
And you're right, because I'm a fitness enthusiast as well. I'm a runner and a lifter. So as you said, climbing mountains with so much weight, where we're thinking about a different type of technology on how to survive, that does clear up your mind. So I had a 7 o'clock meeting this morning. I got up at 5 to make sure I get my run in and be ready in time for 7 o'clock meeting. That does clear up your mind.
So here's our public service announcement for everyone to wake up at 5 a.m. and go on a run. I would love to be able to do that.
Why wouldn't you get up at 5? Don't barely get up at 6:45 and then get into the meeting. Get up, go for a run, and enjoy the meeting.
Yeah, it's always great to get moving in whatever way you can.
Yeah.
But wonderful a little segue there. And I guess part of my motivation.
I love how these pictures, the background pictures, reveal so much about a person. It's like, oh, I didn't know about this part about you.
And maybe this is more motivation for trying to build your applications faster so that you can get outside.
Right? So yeah, it's absolutely. Oh, what a lovely pitch. I love it.
So on that note, I'm going to show you all Spin. So Spin is what we were just looking at, that open source tool, and I've already installed it. So let's just go ahead and look at what the CLI looks like. So there
is a tool that allows you to write or spin a WebAssembly app quickly.
Exactly, and it's helping you scaffold an application. So we'll walk through that with a Spin new, and all of a sudden you have an application scaffolded. And then you can build it with a Spin build, and then you can serve it locally with a Spin up. And then we'll talk about how you can push it to a registry and push it to a cluster. And all of those are within the CLI.
So that's all that complete life cycle, essentially, from development to deployment to testing locally and pushing it out. And I see there is an option here to deploy it to the Fermyon cloud example. So I think that full, from concept to creating a scaffold to the full production is their end-to-end life cycle.
Exactly. And if you'll notice the asterisks here, those are all plugins. So another part of Spin is that it's highly extensible. So you can add a template, you can add a plugin, you can add a trigger. And to talk about the third, this is focused on serverless applications. So the serverless application paradigm, the idea is that you have some sort of application that's triggered, and there are multiple things that could trigger it. So we've talked about HTTP a lot here, but you could also have an event in a Redis queue trigger it, an SQS bus trigger it. Like all these different things can trigger MQTT, all these different things can trigger spin apps, and you can actually add your own new triggers too.
Yeah, and I see there is an ability to deploy directly to a Kubernetes cluster, but maybe we'll talk about that a little bit later. But let's start with the basic life cycle, and then we maybe want to go that route.
Perfect. So let's start with the spin new. And here you'll see we have templates for all these different languages similar to our language guide. You mentioned a Rust developer, so let's go Rust. And what do we want to name our application? Just hello.
Let's call it Mountain. Hello, Mountain.
Hello Mountain. All right, Hello Mountain. Oh, that's lovely. Hello Mountain, and my first spin up. I'll just say that, and then here is where we talk about that trigger. By default, it's going to create a spin app with an HTTP trigger. We can be pretty nuanced about that. We can specify what subpath of an HTTP request triggers this this application. And so if we don't want it to be just a wildcard of everything, we can actually be specific. So let's say only hello, and anything else will be a 404. And then we can go into Hello Mountain, and let's just open this in an editor and see what's been scaffolded for us. So I'm going to go ahead and make this a little bigger.
So this has created a standard Rust application for us now.
Yes. And so if we look at this, all this is it takes in this is our handle. It takes in an HTTP request and it returns an HTTP response. And this is pulled from the Spin SDK, and that's abstracting away a lot of the component model mystery. So you don't need to worry about creating bindings for Rust based on those interface types. We do that for you in our SDK, and you can just focus on building your application. And so this will.
That's the beauty, as you were saying, is simplifying the app development. If Spin SDK was not there, you could have written this application by yourself, but a lot of those bindings, imports, etc., would have to be done manually in that case.
Yeah, or you would have had to use pretty low-level tooling, namely WIT bindgen, to create those bindings. Or with Rust, there's actually cargo component, which helps simplify that for you. So the Rust tooling is quite verbose for WebAssembly, but other tooling is not quite at that level. So it really depends on what language, how intensive an experience it is for you. But this kind of wraps it up into, like you were saying, kind of as simple of an experience as you can to get started with WebAssembly components.
Got it.
And so you'll see here that we just have an application. Let's change it to, all it does is returns an HTTP response with some message in the body. And let's go ahead and run it, and then we'll look at the spin manifest after, and I'll show you how this all came together. So our next thing is a spin build. And so that is building our WebAssembly our Rust application into a WebAssembly target. And we'll go ahead and I'll show you the target after that. So if we
pause a second. You said building into a Rust target. Is that the bytecode you mean?
Sorry, yeah, it's building into a WebAssembly target.
Oh,
and,
WebAssembly target. That's the WebAssembly
we can actually,
bytecode.
Yeah, sorry. It is a WebAssembly bytecode. Sorry, I'm interchanging my words, but
No, that's good. And it's good to get used to that terminology, because end of the day, bytecode may be a formal terminology in which it is sitting, but a developer terminology may be, hey, I'm taking a Rust binary, taking a Rust file and converting it into a WebAssembly target.
Yes. And if we want to look at how Spin Build knew what to do, we can look at our Spin manifest. So this defines our Spin application, and it defines all the components that are part of that application. And we'll see here that we're saying it's that HTTP trigger on the hello endpoint. And then here we're saying, what should Spin Build do? And our template scaffolded this for us. And basically it uses the native tool chain or whatever tooling exists out there. So for JavaScript, we have a plugin that does a little bit with that. And it uses the native tooling to build that WebAssembly, whether you want to say target, bytecode, binary. And so we're actually doing the equivalent of a cargo build target Wasm 32 WASI. So we're targeting WASI.
So when I am saying spin build, behind the scene is looking at this manifest, picking up this command, issue this command, and then creates the target for me accordingly. And if I were to kind of customize it, then I can start customizing the command here.
Yeah, and I will say, I don't think that's something I've heard people do. Maybe not customize your build command because it is kind of specific to the ecosystem, what you'd want here, and we've figured that out for you. But the ways you could customize your spin manifest is by adding capabilities to your spin application. So here, by default, with components, is default deny on capability access. So my component can't do anything unless the runtime is explicitly granting it access to do that. So my Hello Mountain can't send an outbound HTTP request. It actually won't be able to issue that request unless for Spin, we make it so that you can open that up if you specify specific outbound hosts. We also have support for key value stores, SQLite databases, and we'll even talk about how you can do inferencing. But each of those are capabilities that you have to explicitly add to your component. Same with file access. Right now, it can't access any files unless we specify that. And same with environment variables. So this is the manifest where you say all that your component can do.
Gotcha. Okay, wonderful.
And so we've built our component, and we can actually, I want to talk to the, we can see how Hello Mountain was created. Now we have this WebAssembly target, and it's 2 megabytes for our application. So quite small.
So one pause here. Now your name is coming on the bottom left of the screen, and that's hiding. So if you can make your terminal window slightly above.
Yeah, great. Let me just adjust that.
That's
How does that
Thank
look?
you. Thank you. Just right above your name. Perfect.
Good call out. Thank you.
Thank you.
So we've built our WebAssembly application. We did that spin build, and now let's do a spin up. And
this is spinning locally on my machine now because it's 127.0.0.1.
Exactly. So I can just local host 3000 hello, and I got Hello Mountain.
Voila. So
and just to point out that we can only hit certain endpoints, you'll see that if I tried to hit a different path, we would get a 404 because it's explicitly that path.
Gotcha. So in literally 5 minutes, we could create a simple REST application, convert that into a WebAssembly target, and test it. And I can keep iterating on that, evolving on my application as that is happening dynamically.
Yeah, and on the note of dynamic, we actually have a command called spin watch where that creates that dynamic experience. So if I want, I can then have it dynamically rebuild and reserve. And so now if I do it automatically rebuilt, and you saw that it updated there.
This is truly a dynamic experience. So I'm using the IDE of my choice, language of my choice. All SpinWatch is saying, hey, any changes in your code base, and I'm going to spin it up. I'm going to do that spin build, binary target, rehost it, and make it available on the URL. And what kind of changes are possible? Can I add new routes, or can I rechange the entire application? All of that would work with SpinWatch?
Yeah, I can also, SpinWatch is focused on looking at updates to specific files.
Gotcha.
So I wouldn't be able to reset the route, but I believe you could reset the like allowed hosts and stuff like that. But you would need to update one of those files in order for it to realize it needs to rebuild.
Right.
Yeah.
So I mean, there are limitations to it, but still 80% of your workflow would work very well with this, because most of the time you have created the file and you're just checking along. And particularly I saw it was looking at all the .rs files. So as long as you're adding anything into that folder, it'll even pick up that file included as part of your target.
Exactly. And then, yeah, you can always go back into manual mode if you need. And we have a spin build up if you want to build and run in one command. So
Gotcha. So this is my local development experience. How do I now deploy this application in a cloud?
yeah, so we can, because we are talking about Kubernetes, we can focus on that story and talk about how to deploy it to Kubernetes. We can also deploy it to cloud if we want with Fermyon Cloud, but in the realm of open source, we can also just focus on Kubernetes. So for this application I just built, if I want to deploy it to Kubernetes, I need to first make it publish it as an OCI artifact. So with Spin, we have a subcommand called spin registry push.
What is an OTI?
Sorry?
What is an OTI?
OCI, yeah, I think OCI is Open Container Initiative.
Oh, I see. OCI format. Got it. So you're taking the WebAssembly target or the binary and translating that into an OCI artifact.
Exactly. So just as you would do a Docker push.
Yeah, I got it.
And you can kind of equate this flow to similar to Docker. So we just did a spin build, Docker build, and we, instead of a container, we got a .wasm file. And now we're going to do a equivalent of Docker push. We're going to do a spin registry push. And we can use, have you heard of ttl.sh?
I have not actually.
It's a great tool that I'm going to shout out because I'm a big fan of it. So ttl.sh is a anonymous and ephemeral Docker image registry. So you can push up an image instantly and it's public, and you can make it alive for only a certain amount of time. And I love doing it for demos and like dev work because I don't need to go to, if you're using GHCR, make that public. It's just very quick.
Yeah. Wonderful. Oh, that's awesome, actually.
So,
so one thing I was thinking in my head, I built the RS file and I just did spin build. I didn't have to explicitly compile my RS and then convert it into binary. The compilation of the application and converting into the WebAssembly target was a single step for me.
Yes. Which is great. And that was the tool chain provided us that ability. Language tool chains are adding new targets, just like instead of x86 or ARM, you now can target WASI. And so let's go ahead and push this spin app to a registry. So we'll do ttl.sh and let's call it live stream as a subpath and hello. That might not be unique enough, but hello.
Yeah.
And we can specify, we'll just do a couple hours. So this is pushing our spin application to this registry. So once again, you can think of it as your Docker push. And then I actually have a cluster on my Linux box next to me. So if we do you can see it's just a single node cluster. It's 8 cores, 16 gigabytes of RAM. So not too crazy, but pretty normal. And just a single node cluster. And before we run it on the cluster, we need to talk about one more project which made it possible to run this. Which is SpinKube. So
far what we have done is we have only pushed the Wasm binary to the TTL-SH. Actually, sorry, we've taken the WebAssembly binary, converted into an OCI artifact and pushed it to the TTL-SH registry. And OCI is good enough because that's the compliant format that Kubernetes expects.
Yep, and OCI has an ability for different media types, and so this media type is a Wasm media type, and which makes it so that you can bundle things into these quick packages. And it's only 2 megabytes. It's a very small image, so very fast to download and start up. So on the note of how do I put this on Kubernetes, SpinKube is an open source project that came about by bringing together 4 different open source projects on top of Spin. So we have Spin, which is this first of all, it's a way of scaffolding WebAssembly applications, building them, and it's a runtime. It's a WebAssembly runtime as well. But how can you easily take these applications and run them on Kubernetes was the next step. And the Deus Labs folks from Microsoft had created a containerd shim, which is basically a shim on top of or underneath containerd that executes Spin applications instead of containers. And they were using this in their AKS node pools, so you could run Spin apps on AKS. So we took that project, which enables making a Kubernetes node able to execute WebAssembly applications. And then we took the runtime class manager, which Liquid Reply worked on. It used to be called Wasm, which is basically an operator that you apply to your cluster and makes it so that all the nodes have the shim. And they also have the runtime class definition, so that Kubernetes knows to use the shim. And then there's 2 other projects, the Spin operator, which will see that you have applied a Spin app resource to your cluster and create your Spin app deployment. And then we have a plugin to Spin so that I can simply do a SpinKube and all this just happens.
And those are all the projects that are now highlighted on the screen. So I can see Spin operator, runtime class manager, Spin plugin cube, containerd shim. So all of those 4 projects together are what making SpinKube.
Exactly. And if you want to know how to get started using SpinKube, like how to install it on your cluster, because we're going to skip over that just for time.
Yeah.
There's documentation on how to install it in your cluster. So
the SpinKube you will install on your Kubernetes cluster?
Yeah. So let's look at what it looks like post installation. So sorry about that. And make it a little bigger so that we can see that. So the parts of this that are SpinKube are Wasm, which was that runtime class manager. You can see that we had a pod, or I guess a job, kick up and complete. And what this pod did was it basically, for our single node, which is why we have one, it took the containerd shim for Spin and put it on that node. And so now it has it. Okay. And then we have the Wasm operator still listening, because if we were to add nodes to our cluster, it could do the same for those. And then we have the Spin operator, which is waiting for a Spin app resource to be applied so that it can run the Spin applications.
Got it. So the SpinKube is already installed here. I have pushed my WebAssembly target to the TTL push now, ttl.show. What's my next step then?
Awesome. So we have this this OCI image here. So let's go ahead and deploy it to our cluster. And we're going to use SpinKube, that plugin for that. And you can install Spin plugins with the Spin plugin install and specify the name.
And this is only working upon whatever your kube config is, whatever your current Kubernetes cluster is. It just adds the capability to talk to the Kubernetes cluster, but what Kubernetes cluster you're using is defined by the kube config?
Yeah, so your kube config, when you create your cluster, you should have, yes, so SpinKube basically uses kubectl. So it does, it understands what your kube config environment variable is and knows which cluster we're talking about. Was that your question? Okay.
Yeah. So the point is that I could have multiple Kubernetes clusters. On one I may have SpinKube and one may not have SpinKube. So then I can guide it that, okay, go to this particular Kubernetes cluster where my SpinKube is installed and install it there instead.
Yeah, exactly. So you would just configure your kube config locally.
Yeah.
Yeah. And your cluster can have nodes that support SpinKube and don't. And the way you do that is you have to explicitly label the nodes that you want SpinKube on, and that tells Wasm to install the shim there. So you can still have a cluster that has some without the shim, and you can also still run normal containers on a node that has the shim as well. So
gotcha. Okay, I see.
Yeah, it's an add-on. You can think of it as additive.
But even on the node where the shim is installed, I can still run the normal containers.
Exactly.
Yeah, okay, perfect. Sounds good. Let's keep going.
Okay, so if we do a SpinKube scaffold, and we can pass in our reference to our OCI image, and you'll see this hasn't applied it, it's just outputting what we could apply. It creates this spin app resource. And so this is a new kind that we defined. If you're familiar with the custom resource definition concept of Kubernetes, it's basically a way of extending your cluster. You have your operator and your CRD. And so we have the spin operator and we have a spin app. And oh, interesting. Did I? Sorry, I realized that wasn't fully.
I was wondering, like, what is AIM dot underscore 2H? Okay.
Yeah. And what this is doing is it's saying we want to use the shim. We can specify how many replicas we want. So we want 2 instances of this WebAssembly application running on our cluster. We can scale that up and down. You can actually integrate this with the horizontal pod autoscaler or Kata, whatever you name it. It's very Kubernetes native. And so let's go ahead and apply this. So our containers are creating and running. Looks like one had to restart. They might have.
Yeah, that's fine. That's Kubernetes.
And then if we do just confirm they're both running. So let's go ahead and access our application. So if we do a port forward, we can just, and also just to show you a little bit more. The operator automatically creates a service for your application.
Because we're seeing only the pods. We can't access the pods directly, so we got to have a service for that with the port exposed for us.
Right. So we have the service. Let's expose the port. And called Hello Mountain is our service.
Yeah.
And now we're port forwarding it. And so if we do another curl localhost 3000, once again, you got to hit the endpoint.
Port 80 though, right? Isn't it? Oh, there you go. Voila. Beautiful.
Yeah. So Hello Mountain is there. And one of the really great things about WebAssembly is that it has such fast startup times. So we can actually scale this and watch it dynamically scale up and down if we want.
Yeah.
So one cool tool that one of the engineers on my team, Rajat Jindal, made is a reverse proxy plugin to Kubelet. And it also has a way of also watching and monitoring pods. And just to point to it, let me see. Reverse. Here it is if you want to try it out. But for the sake of time, I'll just go ahead and show it what it does. Sorry about that, a little delay. Okay, so
that much more real.
Yeah. So we can see that this did the port forwarding for us, but it's actually because it's a reverse proxy, it'll target all of our pods that are running behind the service. And it's serving it on 9090. So there it is.
Yeah.
But what's also cool is we have this dashboard now, which is showing how many instances we have running.
Okay.
And so let's go ahead and scale up and see how fast that scales up. So if we do a edit or
See, typically when you are scaling up an application in Kubernetes, and depending upon how big your cluster is, how big your Docker image is, which could be big, based upon Ubuntu, whatever your underlying operating system is, it could be a few megabytes. And really, you have to kind of get that image downloaded on each and every node. So that download, each layer, firing it up takes time. So it could be a few seconds. But I believe you mentioned that it was like how many megabytes of the image was for this one?
2 megabytes.
2 megabytes. So I mean, it's a 2 megabyte image. We're not even talking about tens of megabytes. So the download is going to be faster. The startup is going to be faster. So in that sense, getting your WebAssembly app with cloud native is a truly, like a terrific combination.
Yeah, exactly. And for other languages like JavaScript, that you can even see a bigger difference there. Zeiss, who has been trying out SpinKube because they have a serverless solution, they did a keynote with us at KubeCon where they talked about how they were using Express.js apps, and they switched to using SpinKube, and the size of their binaries went from 423 megabytes to 2.4 megabytes. And they were able to reduce the costs of their cluster by 60%. Because they were able to scale their batch jobs so much faster.
I remember that keynote, at KubeCon Paris. So that's super impressive, and I hope it only raises more visibility of leveraging the WebAssembly workloads with cloud native. It's not either WebAssembly or cloud native; it's WebAssembly with cloud native.
Exactly. And to kind of show that scaling, I'm going to scale our spin app up to 50 replicas using SpinKube again. I'll just update the spin app resource. And if we go to here, we'll see how quickly we're going to scale up to 50 instances. And then we could also, you can see it just jumped up to 50 replicas.
Yeah.
And we can see that in our, we can see that we have 50 pods.
It's live already.
Yeah, and then you can scale it back down to.
And you said this is a one node cluster?
Yeah, single node.
Well, that's probably part of it as well. But how well would that scale if it's a multi-node cluster, say hundreds of nodes in the cluster?
It would scale even faster because you have even more compute to be able to scale to. So we had a live code Tuesday, and even for small clusters too. Fermyon does live coding Tuesdays, and this past Tuesday, our CTO showed a 5-node Raspberry Pi cluster scaling up to 50 instances and down, and it was also very instantaneous.
Yeah, because I think the image size is really a big factor here, because that's not a big deal, and because WebAssembly by itself is starting up faster. How much of an overhead the OCI artifact adds to the WebAssembly startup time?
For the shim to handle pulling the WebAssembly module out of it.
Yeah.
So that it's the same overhead you would get with a container, in the sense that you have to, basically what the shim does is it, from the containerd image store, it grabs the OCI artifact and then pulls the WebAssembly module from that and does essentially a spin up within the shim. I don't know the exact number of.
That's okay. Well, that's okay. I mean, if it's a similar ballpark, I think that's the key element here. Now, I know we just had about a minute, and we have talked about so much exciting stuff. Gosh, I could have asked so many more questions here. Do you want to quickly talk about serverless apps and WebAssembly as well?
Sure. And just, I think we've touched on it a lot, but I think the thing that gets me excited about this is the idea that you can do more with less resources. And so we've talked about how with WebAssembly, we can scale up and down faster, which means you can offload resources to do more when you're not doing, because you do your job faster and you scale down faster. So those resources have been offloaded. So the whole idea here is that you can now with WebAssembly use a lot less hardware to do a lot more. And I think that's what's exciting about serverless is kind of reducing our carbon footprint there, and kind of right sizing our workloads. And then another thing to point out that we were hoping to talk about is serverless AI. And so I'll just mention that I had a sentiment analysis demo that I was going to show, but that's fully open source. So if folks want to try it out, we have a repository with all those examples. And I'll just show the image, the page here, and it's AI examples.
Oh,
and so you can run a serverless application that does sentiment analysis. And you can also deploy that to your Kubernetes cluster. And so if you want to get hands-on and try like a really exciting example, that would be one to look at.
That's wonderful, actually. And it seems like, we might be able to do just a dedicated episode on Wasm and AI itself, on all the cool things that are happening around that. So maybe in the near future, we'll bring you back and maybe bring Bailey along with it. So let's talk about what's happening in the WebAssembly and the AI space together.
Yeah, that'd be really exciting. And I think it also fits with the serverless story too. So yeah.
Cool. Awesome. Fantastic. Kate, is there anything that I should have asked and I didn't get to ask for today?
I think you did a wonderful job of fueling questions, and I thoroughly enjoyed this, and I hope people got a sense of what Spin is, what SpinKube is, and maybe a little excited about WebAssembly.
Yeah, no, I mean, this is like we have had at the peak, we had about 200 plus people that are live watching it, which is great. And again, this is going to be available as a webinar on both of our LinkedIn streams. So let's hope we can repurpose it, get some excitement around it. WebAssembly seems to really provide a very good option for people who are trying to deploy applications on Kubernetes and run them faster, get them more efficient, reduce the carbon footprint, minimize your cluster sizes and all. So I think all of those are really good causes for which people should look at WebAssembly.
Exactly.
Awesome. All right, well, Kate, thank you so much. And I hope everybody had a wonderful time and enjoy wherever you are. Bye-bye.
Thank you, Ryan.